Okay, guys, so today we're gonna finish lesson one about distance between 2 points, distance between two lines, angles, and so on. Remember that I'm not gonna teach you about area and volume yet until fifth semester. And the last problem to solve, guys, was the problem of finding the angle between two lines, okay, between two intersecting lines. So in order to achieve this, I'm gonna first explain to you some concepts, A and B, which is the concept of the angle of a line. What does that mean? B, how to find the angle of a line knowing its slope. So let's see how this works. Okay, so I'm gonna draw in here a Cartesian plane, and I'm gonna draw two lines, line 1 and line 2. And whenever you read this phrase, the angle of a line, what that means is this angle, guys. For example, the angle of line 1 is this angle, okay? It's basically the angle that it makes with the positive x-axis. You start in the positive x-axis right here, and then you rotate counterclockwise in that direction. That's why the arrow, and that's what we know as the angle of this line. And the same goes for L2. You have L2, line 2, and if you want to get the angle of such line, what you do is you start in the positive x-axis, which is right here. Well, it's gonna look a little weird, but you do it this way. It's that angle, okay? You start in the positive x-axis, you rotate counterclockwise until you reach the line, and that's the angle. Let's call it angle 2 for line 2, which is the same as this angle, right? Those two angles are the same. But since I told you that you had to start in the positive x-axis, I wanted to start here and not there. But they are in fact the same. Okay, so those are the angles of a line, and only these angles. Because when you draw a line in a Cartesian plane, you can actually get more angles. For example, you can get this angle, you see, etc. So no, those angles, even though they're perfectly okay, there's nothing wrong with them. What we mean by the angle of a line is the one that I told you. It's this one and this one. Okay, so that's it. That's the angle of a line. Very simple stuff. Um, in a moment, it's gonna be very important for us to find these angles, the angles of lines. And I'm gonna teach you how to find the angle of a line when you know the slope of such line. So let's see. How do we do that? One more time, let me draw a Cartesian plane. And first this example. Line 1 with its proper angle, angle 1. And I want to find this angle. What do I do? Okay, what you do is this, guys. You're gonna make use of the slope of this line, slope 1, M1. If you remember, guys, the slope is basically the rise over run. Do you remember that definition? Slope is equal to rise over run. What do we mean by this? Well, when you start in some point, for example, this one, when you locate 2 points in the line, let's call them P1 and P2, and then you go, or you imagine traveling from point 1 to point 2 as if like hiking or going over a mountain. You know what I mean? When you walk in this direction, you can you can actually interpret this as going a little upwards, right? Because you're actually going upwards and a little rightwards. See what I mean? We're going a little in this direction and a little in this direction. And the sum of both motions gets you from point 1 to point 2. So basically, we're doing this. We're doing we're walking in this direction a little bit, or moving in this direction, and then moving in this other direction. And that's what we know as rise and run. And the definition of slope is in fact the ratio of rise over run. Okay, the more rise you get, the more slope you get. Okay, that's why this definition was invented. Okay, perfect. So the slope is rise over run. And when you talk about the coordinates of this point, P2 has coordinates x2 and y2, P1 x1 and y1. Then you can see that this thing will transform into y2 minus y1, which is this little bit, over x2 minus x1, which is this little bit, which is the rise and the run. These two things are completely equivalent. Okay, so how does this slope help me find this angle? Well, if you remember from the definition of the trigonometric functions, which I suppose that you saw in junior high, when you have an angle, let's call this angle theta, and you have a right triangle with catheta A and B and hypotenuse C, then you have these definitions. The sine of theta is equal to A over C, opposite side over hypotenuse. The cosine of theta is adjacent side over hypotenuse, and the tangent of theta is opposite side or opposite cathetas over adjacent cathetas. So it's like so. And this is the one we care about, this one. Why? Because if you notice in here, we also have a right triangle, okay? We have an angle in the right triangle, and we know the rise and the run. So basically, we know these cathetas and these cathetas. So I can write the same, I can use this knowledge, these definitions, and write the following. The tangent of this angle 1 will be equal to opposite cathetas, which is rise, over adjacent cathetas, which is run. Okay, so as you can see, this and this definitions are the same. So that tells me that the tangent of the angle 1 is equal to the slope. I can erase this. I don't need it anymore. So the tangent of the angle 1 is equal to the slope. And finally, when you want to isolate the angle from an equation like this, when it has a trigonometric function, what you do is you isolate such angle by taking the inverse function, in this case the inverse tangent of the slope. I suppose that you have done this already at some point in your life. Please tell me if you have, because we're gonna do this quite often. And right now, I'm not gonna explain to you what this is exactly, even though it's related to inverse functions, which we have seen. I'm gonna explain in more detail what we are doing when we go from this line to this line, okay? But in the meantime, just do it in the calculator to get the angle. That's it. Okay, so that's how you get the angle, guys. The angle of a line, if you know it's a slope, you go like this. Inverse tangent of the slope. Okay, now, mm, I'm gonna interrupt this video because I have to, and I'm gonna give you the example in a moment.